here's another way we can use confidence intervals to see if, or to determine the most likely reason why X bars are different from each other. All right, so let's say that we have a mean for variable A. I don't know what variable A is, but we have a mean, and we have a mean for variable B. As long as they come from the same people, okay, variable A and variable B are measured on the same set of people, you can subtract the two sets of scores, and after you subtract, you're going to get, an answer. It's going to be an X bar, but it's going to be a difference between A and B. And if you draw a confidence interval around them, then as long as 0 is in that confidence interval, the most likely reason why the means are different is just sampling error. Now wait, don't back the tape up, okay? Because I am going to go through this in more detail and repeat what I just said. All right, so don't panic just yet. So the thing to remember though, variable A, variable B, that's from the same group of people, okay? So let's do an example. Let's say we're measuring optimism for COVID, after COVID. So if this is you, it means I scored your optimism. I gave you the optimism test and I got a score for you before COVID hit, and then again after. So this is you as well. Same thing. This is your friend Sally, and this is Sally, and this is Timmy, and this is Timmy. So it's the same group of people, okay? All right. So now we want to know, because we're going to calculate a mean here for the before. So this will be mean optimism before and mean optimism after. Do you think that those two means are going to be the same? X bar before, X bar after. Do you think they're going to be the same? No, there's going to be sampling error. How do we know? Because we sampled. There's going to be sampling error. So the question becomes, why is this mean here different from this mean here? Is it just sampling error, or could it be sampling error plus something else? So what we're going to do is, and this note is reminding you that this has to be the same group of people, okay? So, you, Timmy, Sally, it's got to be the same. All right, so what we're going to do is we're going to subtract the difference between before and after, because we want to know, did these scores change, right? We know the means are different, but are they really different? Did they change from before to after? So if the answer is no, just, theoretically, if you got a 5 here, what should you get here? If there was no change, you should also have a 5, right? If your friend got a 4 here, then he should also have, or she should have a 4 here. If this is a 2, this should also be a 2. If this is a 6, this should be a 6. If there really is no change between before and after COVID. So what you do is you subtract all the scores and you get a difference. Now, if there was no sampling error, we should get 0, 0, 0, 0, 0, 0, 0, right? But there's always sampling error, so we're not going to get 0. Even if there was no change from before to after, we should not expect these to be all zeros. So maybe this one is a 3, a 1, a -2, a 0, a -4, and a 5. Just made them up, okay? Now what you're going to do is you're going to calculate the average difference. So you just take these numbers and calculate the mean. So you can think of this as the mean change from before to after, okay? The mean difference or the mean change, all right? Now again, it should be 0. If in fact there's no difference between before and after, this should be 0. But there's going to be some sampling error. So even if it's, not exactly 0, as long as it's close to 0, we're still going to say, oh, that's probably just sampling error. So how do we know if it's close enough to 0 that we're going to say, oh, it's just sampling error? All right. Now, in order to determine whether it's just sampling error or something else, on top of sampling error, what you're going to do is you're going to either calculate the 95 or the 99, your choice. This one gives you a higher chance of being accurate, correct? But it's also going to give you a larger interval size. So you need to decide, there's going to be a trade-off. Which one do you want? Okay. But you choose one of these, and then you calculate the confidence interval around that mean. You remember you did the mean change or the mean difference? Okay, that was that last mean that you calculated. You draw an interval around it. So what you're going to end up with is an interval. This is going to be whatever number is right smack in the middle. That's the average distance, the average difference that you calculated on the previous slide. So remember you had like the 3, the -2, the 0, the +6, whatever. You figured out the mean difference, and then you calculated the interval around it. Now notice that 0 is in this interval, right? 0 is within this interval. When that happens, you're going to say, well, then it's close enough to 0 that the difference between variable A and variable B, or in this case, before and after COVID, is probably just sampling error alone. Okay, probably. However, what if you calculated what if you calculated the confidence interval around your mean, and it was this 1.7, 2.6? This, in this situation, 0 is not in here. So because 0 is an unlikely event, right? You would have to argue that, it went way against the odds, right? 0's over here, and we're 95 times out of 100, 95 times, oh no. Oh, that was supposed to be the highlight. Oh well. 95 times out of 100, we've drawn this interval correctly. Mu is actually here. It's not 0. All right. So here, if we draw an interval that doesn't include 0, we're going to say the most likely difference between variable A and variable B, in other words, between optimism before and optimism after, is sampling error plus something else. There's something else going on. We didn't get a mean close enough to 0 to be able to say with confidence that, oh, it's just sampling error. Okay? And that is the end.